All right. Good morning, everybody. Welcome to another installment of Autodesk Virtual Academy. The date is August 19th, 2021. We got a great session here for you today. We have a particular guy. His name's going to be Philip Cox over here. I'm not sure if my video camera is showing right now, actually, but can you guys, or can you turn on your camera, Philip?
Yeah, camera's on. I can see you
Oh,
too.
oh, perfect. Oh no, shoot. That's fine. Okay. Good morning, everyone. Thanks for being on here today, Philip. Yeah, we got a series over here. If you guys are familiar with Philip Cox's previous sessions over here, they're actually building through a different series of topics here. And I know this particular topic has been requested time and time again, and is very much a large part of of KETIV's bread and butter projects here and available. Philip, can you tell us a little bit about yourself and kind of what we're going to be talking about here today?
Yeah. So I guess I'll start out with, should I go on to the background slide there? Go to the
That's fine. Yeah, perfect.
So I am an application engineer at KETIV. So which means that I develop software solutions for clients. So clients come to here, I'll turn off my video too if we're looking at. There we go. So clients come to us wanting to automate different processes, and we help them do that. And I write code a whole bunch every day, all day. But my background, I am from Brigham. Well, I graduated from Brigham Young University in mechanical engineering, but I did a lot of coding while I was there with CAD. And so when I graduated, I worked at General Motors in their knowledge-based engineering. Worked on a whole bunch of projects from drawings to wiper blades to a bunch of different stuff. And then after that, I also worked for the Autodesk education field team, teaching Fusion 360 to professors and students. So a lot of different type of roles, but I also, as you can see in the picture, am a father. My 5-year-old just went to his first day of kindergarten. So that's kind of my background.
Congratulations. You're a father, but you're also a Monsignor as well. Is that correct, Philip?
Monseigneur. I speak a little bit of French, more Spanish than French.
I see. I see. Right on. Where did you learn Spanish at exactly? I think you told me you were fluent earlier. Is that right?
Well, relatively fluent. I'm not native, but
I see.
I did live 2 years in Mexico on a mission as a missionary. So I learned it for about 9 weeks before I got dumped in Mexico with somebody who didn't speak English except for movie quotes. So
that's good. Well, I'm glad you know some of these programming languages, maybe a bit more than some Spanish. Then, all
yep.
right. Yeah, thank you. Thank you for introducing yourself. And just before we get into the rest of the presentation, guys, this is a Zoom webinar, and so if you guys aren't familiar with some of the controls, you could expect some poll questions to be showing up. If you want to interact with us, ask questions. There's a Q&A panel in your action panel over there, and also a chat menu where I'll be posting links for relevant stuff that comes up in the presentation, and also be on the lookout for, I guess, any audio things or issues. If there's any problems with that, let us know. And there will also be a survey at the end of the presentation for you guys to provide feedback, so just a reminder. But with that, Philip, go ahead and take it away if you want to jump back to the poll slide and get this party started.
Yeah. So we have a couple of poll questions, and I guess Adam's going to put them up on.
Yeah, does that show on your screen? I don't think
it does.
Okay, perfect.
Do you want me to read them off, or
go for it? Yeah, please.
Okay, so the first poll question is just kind of how many of the series of the videos have you seen? So there's 3 previous of them. First one was getting started with Visual Studio, where we went over just kind of connecting Visual Studio to Inventor and getting an add-in going. It didn't do anything. I think we made it launch a message box. Then the second one was creating basic geometry, where we actually made, the button pop up a form and do stuff. I think we made it make like some circles or cubes or something. And then the third one is really where kind of the rubber started hitting the road, of where we talked about pushing values to Inventor parameters. So we start with a template part, and copy that over and then push the values that the user puts in through a form to those parameters, editing the part. And so we're actually going to talk that's our starting point for today. But then, of course, last option is none of the above, which is great. That means you have more viewing to do, right?
Homework. Oh man, what do you mean?
No, I'm sure we have some experts on here that probably can get by without going back and reviewing.
No problem. Yeah, because I know this is kind of a pretty broad topic, and so it is good that we have a starting point to kind of build on these concepts and stuff. And I know the drawings in particular are a very common topic that people request to automate. And we could see in question 3 as well, there's some potential topics you may be interested in, and automating drawings is leading it right now with about, small lead over there. Part generation, assembly generation, simulation has also been something you could potentially simulate as well. And we're also open to any other ideas too. If there's anything else you guys would like to automate, and feel free to let us know through the chat as well.
Yeah. Also, maybe one of the things that you could put in that other is if you're interested in, more kind of basic programming standards. We talk a lot about, interacting with the Inventor API and stuff, but we generally don't get into things like, okay, what's the best way of, making classes and organizing our methods so I don't just have a long, big script of code that's not reusable and hard to maintain. So that's another option that we could look at.
Yeah, absolutely. I'm going to cut the poll here, and let's see what we got. And you can see the kind of trends over here. We have about 60% reporting over here. But yeah, so pretty good spread across over here. Any particular thoughts with these? I'll share the results with you. Any particular thoughts on this distribution? Yeah.
Should I pull it over to the screen so people can see?
Yeah, why not? Let's take a look. Let's see.
Okay. So, hey, look, we got a good percentage that have seen at least the first video.
That was encouraging. Yeah.
Yeah, that's pretty good. Then we'll go down here, level of familiarity.
A lot of people like talking about iLogic. Yeah, absolutely. Yeah. So some people have used iLogic. Object-oriented practices is going to be important as well. And then API is a larger conversation too, but that looks pretty good. That's, I think, what we would expect from this video series so far.
Okay, and then, yep, 91% drawings. That's why they're here.
Okay, yeah, give them the good stuff. Hurry up and get on with it here, Philip. All right, that's interesting stuff, guys. Again, if you have any other comments, feel free to put them in the chat if you have any additional information you'd like to share with us. But otherwise, I'll let Philip get to it. Thanks again, Philip, and thanks for filling out those surveys, guys. Thank you.
Okay, so we'll go through here. So we've kind of talked about the review of past trainings already, so I'll go quick on this slide. Here's kind of the YouTube if you want to go find them later on, give you a preview of how long it's going to take to go through it. But it's catch up and want to kind of go through those. So let's talk about our starting point. In our last training on pushing parameters, this is kind of where we ended. We had an application with this form where the user could input an asset path for their where their template part was saved and its name, and then also a new file name that they wanted to copy that to, and then how they wanted to change the parameters and location within an assembly. So, I mean, that's kind of what we've done. And now we're going to kind of go forward on that. So what we're going to do today is we're going to create a drawing file. Now, in order to do that, there are a couple extra steps like making a button, but that's the first thing. After that, we're going to place a base view and 2 projected views. Okay. So I think it's an ISO and like a top or front view. Then we're going to create a custom table. Now, there's a lot of different things that you can use a table for in Inventor drawings. We're going to use it kind of as a pseudo spec table where we'll record all of the inputs that the user put into this form in a table on the drawing. But obviously, you can use this method to create whatever type of table you need. And then finally, we will place a couple dimensions. I think we're going to do a grand total of 3. So 2 radiuses and a width, and show you the process of doing that. Placing dimensions is probably the most in-depth of these steps, because for each dimension, there's several steps that we'll go through. So that's kind of what we're going to do as an overview. So let's jump on in. So first, we're going to be creating the drawing, like I said. And if you remember, we have the standard add-in server that we set up in our very first AVA of the series. And we're going to go edit 4 different places of code. Each of these are going to be a line, except this. I think it's going to be like 3 lines of code, but pretty simple. And I'll show you where that is. And that's going to give us this little add drawing here in our ribbon. Then we're going to create a new class along with a constructor. And I'll show you kind of how to do that. You can see the menus over here. And then we'll add in a couple lines of code just to get our drawing document up and running. So let's go ahead. I'm going to pull the PowerPoint over here for later use. We're in Inventor. I'm going to show you just really quick where we are. So let's go into Tools. We're in an assembly, so that pulls up our last series form. And if we go ahead and push the parameter button, you will see, boom, that's where we left off. Okay, so now I'm going to come into here and show you a little bit of the code. So let's go to standard add-in server. And remember, I said there were 4 different places. First off, we need to instantiate the button. So we've kind of done this in past series, but so this will be a little bit of a review. Here, we need to create a variable. Then we need to create the button definition and assign it to that variable. So you can see that here we're naming what's going to show up that text on that drawing. Then this is a unique name, so it doesn't really matter what it is, it just needs to be unique. So you could name this internal name 3 if you wanted to, but I find it easy just to name it after the button. Then the 3rd line of code is we actually have to put it on the ribbon, or else we wouldn't be able to find it and click it. So here, down in this user interface definition, we are going to, you'll notice that we have the part ribbon and assembly ribbon. So the button that we did last time was on the assembly ribbon. This time, we're going to just copy this sample button that goes into the custom panel, which is on the part ribbon. We're just going to copy that 1 line right here and add in our add drawing button variable. So that will add that to the ribbon, so it will pop up. But currently, if we click that, it won't do anything. It'll just click. So we need to add in an event handler to handle that button click, and that's right down here. So you can see there's other event handlers, and you can just copy that and change it so that it's handling our button here on execute. This name doesn't matter too much because we're not going to actually call this method anywhere, but we just need to make sure it's handling that button on execute. And then this code is going to make a new object of class AVA drawing. Now we haven't made this yet. I mean, I guess I've made it as an example, but I'm going to now jump into we make a new class. So this is mostly review of how to make a drawing, but or make a button to launch our drawing. But now we'll jump into the new stuff of creating a class. So how do I create a class? In Visual Studio, if you haven't done it, you can come over here to the project. So this is called the project on the Solution Explorer, and right click on it And that will give you this add menu. Oh, I'm running, so I can't add a class. Let me stop the debug and add a class. So right there. There's a lot of different things you can add, but we'll add the class. And then that will launch a form. And just make sure you're on the class and you name it. So I'm just going to name this example because I'm going to delete it because I have already one made. You'll notice we have a class template. So that's a useful thing. Ours just has some formatting stuff that's useful, that if you have a team, making template can be useful. So you don't start at ground zero. Oh, that's right. Yes, I do want to replace it because that one was for practice. So here we make our class. It looks really complicated, right? It's just a couple lines. But what we're going to want to do in class is make a constructor so we can actually make an object of that class. So in order to make a constructor, I'm going to want to make, say, public sub new. And then I can just put parentheses and hit enter. And there's our, and so this will get called anytime you want to make a new object of this class. Most classes, in fact, I can't think of a reason why you wouldn't have a constructor on a class. You're going to have a constructor to get started. So that's kind of first making a class. I'm going to go ahead and delete this because I don't need it. We have one right here. We'll jump into our AVA drawing class. So you'll see here's that constructor. It actually has some code. I've commented out a bunch of code, and we'll march through it step by step to kind of explain what each line of code is doing. But in our constructor, every time we instantiate a new object of AVA drawing, we're going to set up our transient geometry object. We're also going to grab this part document and store that just off the active document, so whatever's up. And we're going to make a drawing. In documents, add, and then you add the type, which is a drawing document. So you can kind of see that there. This is a line that you can find off of the Inventor API documentation. And we go into that in previous sessions. So then this line is for future use. I just didn't comment it out. It just grabs the active sheet. So let's go ahead and run this. I'm going to launch Inventor. And it'll open up off screen. And we'll run this code and see that it indeed will open and generate a drawing for us. Then I'll show you kind of how you can start debugging with Visual Studio, which is very helpful. And also will cut down on the time to edit code. So here, let me open up the assembly. So remember, if we want to make our widget, we got to be in an assembly to find our button. So let's go ahead and push parameters. We'll just do another default one. And then we need to be in the part to see our button, because right now tools, we only see this button. Where's the add drawing? Well, if I come to this part and open it up, then go to tools, you'll see we have our two different buttons that we had in that standard add-in server. So I'll go ahead and hit add drawing, and boom, it made us a drawing. Now we probably should put some stuff in it, right? So what I'm going to do is come back over here to the code and drop a breakpoint. Breakpoints are just places where it'll pause the code so that we can check values of things and step through it line by line. So let's go back. I'm going to exit out of the drawing so it doesn't have a problem when we run this again, and hit our button again, and boom, we hit the breakpoint. So now if we wanted to, we could come through and see different values, logic and whatnot. But let's go back to the PowerPoint. F5, there we go. So now we're going to create some views. So we're going to create 3 different types of views. The front view as our base view, and then ISO and top view. So it's going to be 3 lines of code. So pretty simple. Now, one thing, if we just started editing code without hitting a breakpoint, Visual Studio would get mad at us, and because we're actually running in debug mode. So why I put the breakpoint in is so that we can do some minor edits. If you change too many things, like adding in different functions and stuff like that, it will tell you need to stop debugging and rebuild. But this is just kind of a trick that I use, so I don't have to run through the process of getting a part up to a point where I can test it a bunch of different times. So it's kind of a little tip here. So I'm going to come in here and uncomment the next lines of code and talk about them. So here we go. So the front view, how we're going to get the front view is we get that sheet from the active sheet that we defined earlier. We're going to call drawing views off of it and add a base view. Okay. Now base views need certain parameters. So I'll go in here and bring up this. If I delete a comma and then put it back, it'll show what variables that we need. So first it needs a model as a document. So that's the part document that we put in there. Next it needs a position that we're going to put this view. So that's where we're calling off the transient geometry object, create point 2D, and then we just put in the point we want. Then a scale, so we're scaling it half. View orientation. So this is an enum that Inventor has, where we're just going to grab the front view orientation. You could change it to be whichever one you want as your base view. Then the view style, let me scroll over here a little bit, is we're going to do a hidden line drawing. You could do, here, I'll show you different options here. So from base drawing view style, which doesn't make a whole lot of sense because this is the base drawing view style, but you can do hidden line removed, shaded, and shaded and hidden line. So those are kind of things you can do. We'll put it back on hidden line. And then over here, we can, we're going to do the 2 projected views. So now that we have our base view, we'll make our top view, and you'll notice we once again do sheet drawing views, but this time we're going to add a projected view. And the first variable references that front view because we need to know what parent view this projected view is coming off of. Then we need to know where to put it. So once again, we create a point 2D. And then we're going to put in the style, which is this K from base drawing view style. So now that we have a base drawing view that this is based off of, we can just say, hey, whatever that is, do that. You'll notice that the one below it, we're going to take out the hidden lines because we don't want them in our ISO view. So those are the 2 drawing views. So we can go ahead and say, hey, continue. We don't need to be paused anymore. Let's run this. And this time, I'll create the drawing, and boom, there are our 3 views placed where we want them to be. So you can see hidden line, base view, then the 2 projected views. Cool. So let's go ahead and we'll close this out and jump back to our breakpoint and do the next step. Bring the PowerPoint back over. Okay, so the next step is creating a custom table. So for this, we're going to make our own method. I don't know if you guys have done methods before. We're going to do, there's 2 kind of types of methods, subs and functions. We're just going to do a sub on this. I'll talk about the difference of those 2 and maybe give an example. But we're going to grab parameters from that part document that we've copied in our previous series and fill in this table. So we'll go ahead and get to that. So I'm going to pull this over. Once again, we're at a breakpoint, so we can edit. I mean, I could stop this, but then I'd have to run, open up Inventor again, and that would take time. So we'll go ahead and uncomment. So this is our call for our function, but it's yelling at us because it's like, where's that function? So I'll go ahead and uncomment out that function. There we go. So this basically jumps us in the code down to here. And let's look at this. So I'm going to start actually on the bottom. I mean, Sound of Music is probably not a very good place to start, but it will kind of help us explain what we're doing up here. So to make a custom table, we're going to go into the sheet, custom tables add. Pretty simple. What it's asking us for is first a title. So I called it specifications. Then a placement point. So this is all pretty basic. We know those things. Number of columns and number of rows. So 2 and 5. My table is going to be static. Yours could grow based on code. Could write some code to make the number of rows go longer, a certain variable or whatnot. Just be careful because this will break if your number of rows and the actual amount of contents you're putting in don't match up. So keep that in mind. Putting this in a try catch is probably a good idea. And maybe I'll show you a try catch here. So the next one is this column title. So this is an array of strings. See kind of the nomenclature here of the squirrely brackets with 2 strings here, comma delimited. That'll give us our 2 column titles. Next is this, the table contents. So this is a string, a list of strings that I've made, and then I'm calling to array because once again, Inventor likes taking arrays. So I'll go into that later because we go through a process of adding stuff to that. But then the last one is an optional column widths that we are just going to adjust the widths so that our table looks prettier. So I want the first column to be 5 and the second one 2.5. So table contents, let's look at that. So this call needs just an array of objects. It's not specific on the type of objects to fill in the table. Now we're going to give it strings because that makes the most sense. But we need to fill that array up. And so we do it by, the list object has a nice toArray function off of it, and I like lists better than arrays. So I dim up a new list here of strings, and then I need to add the stuff in it. So the first thing on our form was cylinder diameter. So I, add that in. Then the next line is actually going to be the value of that. So that's, the first row, column 1, second row, column 2. And here, we don't want a static number. We want to actually grab it from the parameters of the part we're making the drawing off of. So in order to do that, we need these parameters. So we grab that part document that we passed in, and we grab the component definition, parameters, and user parameters off of that. So we get all the user parameters. Then for each different user parameter we need, we go ahead and call .item and pass the name. Now this name needs to be exact, including capitalization. So make sure you copy it right, or it won't find it. And I think it might even error out if you get it wrong. I can't remember. So we're going to store that user parameter. Now, important thing to note is this user parameter is not the value. It's just the actual object. So when we use it, we have to call .value on it, or else it won't understand what it is. So for that, it's going to give us a double, I think, for this one. And then we're going to it gives Inventor works in centimeters. So remember that when you get funky numbers out and you're like, that's not the number I put it, and it should be. We convert back to inches here. And then this is a string, it's just square or circle, so we don't need to convert it or anything. This one is, just an integer. And here we have a conversion for the whole width and the distance to center. So there we go. We got all of our table of contents added and we put it in. So there is the custom table, and we'll go ahead and run it. So we'll continue, and here's our little custom table that we made. So how about we pause here for a second? Adam, are there any questions up to this point?
None so far. Someone is asking about example documents, and I think we discussed that already. I think it would be great if we could upload example documents with the recording when it goes up on the YouTube channel, but did you have any thoughts about providing sample data?
I think we can get the PowerPoint out to people at least. And
sure.
I put the kind of example code up there so they can look at it.
I got you.
That might help.
I got you. Okay, cool. And then can you give us a quick summary of, I guess, because you've done 3 things so far, right? You've made some code to make the drawing, make the views, and make the table. Is that right?
Correct.
Cool.
So,
okay, and then we're clear on the YouTube side as well, so no other questions outstanding.
Okay, well then we'll continue on. Let me grab the... So our next thing that we're going to do is actually add dimensions. So this is a little bit more involved. We have a couple steps here. And the first thing we're going to need to do is we need to know which faces and drawing lines that we can grab. Because normally on drawings, the user can just click where they want. But here we're going to have to do it automated. Which is a little tricky. So first we need to attribute some faces, and Inventor 2020 makes it a little simpler. They've added a new option where you can right click on an object, and as you see here, you can assign it a name. And what that is going to do is it's going to create an attribute. And we'll look into that. And we're going to use that attribute to grab the object we need. So let's go and do that. I'll go ahead and get out of the PowerPoint, put it over here. And I am going to open up our template part. So this was the template part that we copied to be our part document that we're using. So this is not the part document we've created, it's the one we're copying from. So here we can come in and right click. And if you notice right there, assign name. Now, if you're using a previous version of Inventor than Inventor 2020, this won't be here. There are other ways you can do it, and I'll kind of talk about that. But you can just click here and hit assign name. And you'll notice I've already assigned name to several things, and I could type name in here, hit OK. I'm going to hit cancel because we don't need another one. But you can see we have top face, bottom face. This green is really hard to read. Outer circle face because we need that radius. And the top and bottom will give us what we need for the width dimensions, though we probably could get it with this outer circle face. And then this face over here, I think. Where's this one? Oh, that one. For our, I call it the first circle face. I call it the first circle because if you remember, we can change the number of holes here. And I wanted to make sure I grabbed the first one. So if the user put in only one hole, we wouldn't lose our hole dimension. Also, if you want to kind of see where these are, if you go over to your iLogic tab here, open up your geometry, you'll notice that there are the 4 ones right here, and you can come in and edit them if you wanted to. Double click and you can change the name. Now, For those that are not in Inventor 2020 or beyond, or there are other ways that you can kind of do this. If you go, I'm going to go into tools. There's an attribute helper that you can get that will allow you to name faces without the assigned face. The assigned face just makes it a whole lot simpler. So, and this will show all these different attributes that we've already made. So in this, now I can right click and add an attribute set and do it that way. However, I wanted to show you something. So let's pick this bottom face that we've assigned name. So what it's actually doing is it's making an attribute on that face. It first makes an attribute set by this name, iLogic entity name set. Okay. Then it makes a attribute with the name iLogic entity name. And then the value that we put in that bottom face text is actually the value of that attribute. So you got the attribute set, the attribute name, and the attribute value. Okay. I don't know what this attribute is doing here. Maybe it makes it automatically, but you can see we have that for top face, all four things we've attributed. Okay. So if you make it through the attribute way, I'll go ahead and, I don't know, attribute something here. So let's say AVA set. Go ahead and right click and add an attribute, and we name other circle.
And to be clear here, Philip, you could name faces and attributes on part files, and can you also do assembly files as well?
Yes. So you can attribute parts, you can attribute most things in Inventor. So
it'd be the same process if I was in an assembly, just right click and then assign name or so.
Yep.
Okay, cool.
Cool. Good question. So I'll go ahead and add that one here, and you can kind of see this one doesn't actually give it a value. We named the set and the name, but if I wanted a value, I can put it here. So we're not actually going to use this, so I'm going to delete it, but just to show you the process of doing that. Okay, so I'll close that and close this down. Now, obviously, you'd want to save after editing that. And now our template part is ready for attributing. But remember, currently we're running our drawing to the copied part, and so it copied that template before we made those edits. So at this point, if you changed your attributes, you'd want to close down, stop debugging, run the whole thing again, make another copy, because you'd need to go grab those attributes. But we didn't actually make changes because I made the things beforehand, so we can keep going in the sake of time. So we're going to go ahead and hit our breakpoint again so we can edit some code. Go boom, right there. And we're going to now add some radius dimensions. So let me pull this PowerPoint back over so we can talk about a couple things. Okay, so these are the two radius dimensions that we're going to grab. And the code that we use, sorry, it's a little blurry because I made it a little bigger. In order to grab that face that we just attributed is this find objects. Okay. So here we're going to, there's three values in the find objects, and they correspond to that attribute set name, the attribute name, and the attribute value. So when we were just using the assign name functionality, remember it named these two itself. And then we went ahead and named this one, or put the value in. So what we are going to do, because we use that way, is we're going to put an asterisk in here, meaning, it's just a key that says, we don't care about this one, get whatever, get them all. So it's not going to filter based on these two, but we do want the one that says outer circle face. So if we put in 2 attributes in there that had outer circle face, it would grab the first one based on our code. That's item 1. But we're not going to do that. We just only attribute 1 face with that value. So, and then I'll run through this code with you in Visual Studio. So this is a little heavier on the code stuff, but we'll get through it. So I'm going to go ahead and uncomment that out. It yells at us because our function isn't there yet. I guess our method. Okay, so we're passing into this method a sheet, a top view, because we needed the view to place our dimensions on, and a part document. Okay. So we'll grab the transient geometry to be able to create points again. And the first thing we need to do is grab that face. So we're document that we copied. We're going to go to the attribute manager and call find objects. Okay, and there's that find objects code or call. And we're going to, like we talked about, put in the star, star, and then outer circle face. And that's going to give us a list of types. Okay, and we're going to call dot item on that. We're just going to grab the first one. Inventor does not do zero-based lists, so remember that. Or you'll put in a 0 and it breaks, and then you'll remember it. And we're going to C-type it as a face, because basically this call doesn't know what type of object it's getting. And so we have to tell it it's a face. Trust us, it's a face. If it wasn't a face, this would break. But since we attributed it, we know it's a face. So that will give us our outer circle face. And we'll repeat that for doing, the circle hole over there. The next step is we need to get the drawing curves off of that face. So we're going to grab our view. We're going to do the top view. We're going to grab all the drawing curves off of that, and we pass in a face. And that will get all the drawing curves generated by that face, which should only be 1, right? Because, it's a cylindrical face. We're looking right down at it. It's just going to make a circle. So then we have to go ahead and grab that circle, because this is kind of an enumerator list. We'll call item.1. We just want the first one because there's only 1, or should only be 1. And then we will, with that drawing curve, we need to make a geometry intent. And Inventor drawings use geometry intent to dimension to. So anytime you're going to dimension to something, you have to take your curve and turn it into a geometry intent, which is, pretty easy. You just go sheet, create geometry intent, and pass your drawing curve in. So that gets us to our geometry intent. So since it's a circle, we only need 1 because we're just going to get a radius. So here in this line, we're going to call sheet drawing dimensions, general dimensions, add radius. Now the radius, it's going to need a point. So that's what we're doing on the line above it, is telling it where we want to actually place the text of this dimension. And then it needs, the curve it's actually going to be dimensioning, which we give it to the geometry intent right there. So to get this point, we're just making a point 2D. I call the position off of the get the X one, that will put us in the middle, and then say, hey, I want to put it 10 to the right and 5 north of that. So, and then we do the same thing for a hole. Grab that first circle face, get the enumerator, get the drawing curves off of that, get the first one, which, because it's circle, there's only going to be 1, and then pass that intent in to our radius call. So there we do it twice. Let's go ahead and run the code. So I just went ahead and hit F5 as opposed to going and clicking on it, but there we go. There's our whole radius, and there's our outer radius. And you can grab and drag these away just like normal. But if you wanted to change where they came in, you'd change that point you passed in. So let's say you wanted, keep grabbing the wrong thing. You want this one over here. You just need to give it that point. Okay, so there's our first 2 dimensions. Next, we're going to put the width in here. So is there anything new on our PowerPoint that we'll look at? Doesn't look like it. Kind of the same type of thing. We need 2 of them now because we're going to go between these 2 parts. Okay, we're going to do a linear dimension, vertical one, and we'll look at that in the code. Let's pull this over. Okay, let's kill our drawing. Hit this to hit our breakpoint again, and look at this width dimension code. Hey, look, we're at the bottom. This is our last thing we're doing. Awesome. Okay, so we've already attributed the top face and the bottom face. Okay, so this is going to be mostly the same for linear. So we're going to grab in. Now you'll notice I have some code in here that gets the part document from the front view. Now I went in and replaced this on the previous one, and I'm going to do the same thing so it's not too confusing. But basically, it's just getting the reference document off of the front view and then C-typing it to the part document. But we passed in a part document, so we don't need this. So I'm going to go ahead and replace, and all of this right here, all that does, well, it just gives us the part document. So let's get rid of that. There we go. That looks cleaner. So we're going to call part doc attribute manager find objects. You've seen this before. Grab that face, the top face. And then we're going to grab the curve numerator. Now the top face on this should just give us 1. Yep, that's right, because we're looking straight down at it. Now, if there was a face that you grab that's going to give multiple curves, so let's say we grabbed that the outer circle. Outer circle, looking at the side of it, is going to give you 4 curves, right? It's going to be a rectangle. Then you'll want to insert some code here to grab the top left, or your top right corner of or curve, most curve of each of them. So that's a little more complicated than we're going to get into today, but maybe that's something we can come back to. But this one, it just gives us 1 curve, so we're going to grab that one and put the geometry intent on there. Okay, then once again, I'm going to simplify this up because we passed in that part document. There we go. And we'll get the bottom face, get the curve candidates, bottom drawing curve, get the first item there, pass it into the geometry intent. And then we'll create a point where we want to place it. So I'm placing it in the middle Y position of the view, and then 10 out from the X. Okay. Then the last line that we call is generating that linear dimension here. So sheet, drawing dimensions, general dimensions, add linear. And here we're going to drop in the width dimension point where we want to put it, that dimension, where the bottom geotent. So linears here, I'll do this so you can see. Linears allow you to put in 2 intents. You don't have to, because like if we just gave it 1 drawing curve, it would know how to put something on there, but we're giving it 2 drawing curves, so it goes between them. And then those are those 2, and then we're going to give it a type. So this is a vertical. We could give it aligned. I think if you don't put anything in because it's default, it'll default to aligned, or it'll just do its best guess. I generally just tell it what to do. So this will be a vertical. And that's it. So let's go ahead and run the code. Boom. So there's our linear dimension. So now if we ran this from the beginning, let's actually go ahead and do that to kind of wrap up. So I'll go ahead and close this drawing. I'm going to, actually, let's just close this down, save everything, and run it from the beginning. And we'll make several instances of this and then go in and make drawings on them automatically. So while we're waiting for that, are there any questions?
We do got some here that I could speak to. Let's see. This is a question from earlier, actually. Dennis had asked, can you locate the table in a specific place on the drawing? And I think you showed the code earlier, but I believe the answer is yes, with the XY coordinates, correct?
Correct. Right. So as we call the table, one of the calls right here.
There you go.
Is placing that point.
Those are just Cartesian coordinates based on like the bottom left corner of the drawing. Is that right?
Yeah.
Okay.
Yep. So I could pass in, like if I wanted it above a certain view, I could do kind of what I did before with, using this top view dot position.
I see.
Base it off of that. But yeah,
beautiful.
Good question.
Yeah, absolutely. And then I know you showed us how to do, I guess, circular dimensions and also the linear dimensions as well. I'm assuming there's a way to do center lines, to place center lines automatically and dimension to center lines automatically as well. Is that possible here?
Yes. The API on drawings in Inventor is pretty well rounded. There's a lot of stuff in there. So maybe we'll go into, I think there's a lot of AVAs on more advanced stuff for drawings that we have.
Absolutely. Yeah.
But if we want to kind of continue on and dive deeper into what you can do with drawings, we can definitely do that in a later series.
Perfect. Thank you. Okay.
Any other questions before we?
I'll save this next question for a bit later at the end.
Okay.
Go ahead.
Cool. So we're just going to, in this assembly, we'll go ahead and put the default one in like we had. But then let's go ahead and change the name so it doesn't yell at us. And go ahead and change some stuff. So let's go ahead and put 8 holes in. I don't know, put 1.5 hole width. We'll go ahead and put it out to 5. Make sure that's not gonna blow up. We'll do 4.5. Always have to make sure that the stuff you're putting in is not going to blow up your parameters. Okay, and we'll shift it over just so we can see it a little easier. Go ahead and, so there's, we did this last time. So there's another one, and we can go into each one. So we did that. Let's go into this part. Open it up. And go to Tools. Add Drawing. Oh. Should have gotten rid of the breakpoint for pizzazz. But there we go. Boom.
Beautiful. Look at that. My God.
So in a matter of seconds, we have all of the stuff that we edited. You can see that the different values came in from the parameters. And we could, come back here to our assembly, open up this part, and come to Tools. Add Drawing, see if the naming convention, nope, there we go, boom.
Beautiful. Yeah, imagine all the time saved right there, guys. Oh my God, that ROI is insane.
Yes.
I know setting up the drawings is a very common thing, right? Or it's not terribly complicated, but it is very time consuming and tedious at times, right?
Yeah, and the nice thing is, this is an Inventor drawing. I can go and add more stuff in. So if you only have a certain basic amount of dimensions and tables on each, kind of as a starting off point, set that up automated, then you can come in and tweak things and add additional notes and things that you need.
Yeah, because it's all technically still Inventor, and you could still do everything you want to do with the drawing after it's been made like this. That's perfect. Um, okay, cool. And then we are at the end of the hour over here. I don't think I could take any more questions over here, but do you have any other I guess last sayings here as we close out the presentation? I think you have a few more slides, right?
Yeah, just kind of some notes. So we, as part of the automation team here at KETIV, we do a lot of, these type of automations of drawings, part configurators and stuff like that. So I won't it's a lot of fun, and keep your mind open for opportunities to automate while you're doing something. Anything that's tedious, you'd be like, oh, I bet we could automate this with the API.
Yeah. The answer is almost always yes, you could automate it.
There are some things that come in.
I'm sorry. I'm sorry. I don't get too excited.
Yeah. And then also next steps. If you're interested in learning more, or you have specific questions for me, feel free to email me at my email here, philip.cox@ketiv.com. We can set up a short conversation, talk about stuff. KETIV's automation team also offers mentoring. They do automation projects that vary on scale to topic a lot. Like the type of things that we get into are always very interesting. And then you can visit the website for the consulting services as listed there. And as always, keep a lookout for future AVAs on this and other topics. So
yeah, absolutely. Yeah. Thanks again for being on here, Phil. And like Phil was discussing, Philip, I'm sorry, was discussing, yeah, this is very much intended to be a jumping off point. And so there's a bunch of other videos in this series if you guys are interested, which I've linked in the chat previously. So feel free to check those out. And of course, feel free to reach out to us to continue the discussion, learning more about automation, and driving your company into the future with innovation. Right. So thanks again, Phil. The recording will be available online later. Expect a survey after the presentation goes down over here for some feedback. We love anything back, and apologies to anyone that asked some questions I wasn't able to get back to. I think that's all I got. Yeah, thanks again, Philip. Thanks again for everyone for being on here, and we'll see you again next week. Okay.
Yeah. Thanks, everyone.
Bye all.